Hey, and welcome back to Rust in Audio. Today we will look a bit into audio buffers and how audio data gets actually stored. And I think it's a very nice example for iterators and how they work, because at the very beginning I didn't really understand what's the difference between iterators and arrays. So let's just check it out together. I prepared a little test here to explain how audio data gets stored. So there are three common ways that you find out there. The first one is stacked data, what I call it like this, but you could also say de-interleaved. This is how Juice, for example, gives you the audio data inside of the plugin process function. It's grouped by channel, so we have one vector that stores the first channel and another vector that stores the second channel. So they could be stored at different places in the memory, but you will have both of them together in one vector. Yeah? So it's a 2D vector, maybe we could say this. Here you see channel 1, channel 0, channel 1, and those are the frame counts. So they repeat here. The second option is sequential data, or at least I call it like this. This is as well grouped by channel, so it works exactly as the stacked data, but we have it this time in one large vector. So they all are stored in the same array. And with interleaved data, it's just the data layout is different. So this time we group it not by channel, but we group it by frame. So the first frame is together, the second frame is together, and then the third frame. But the channels are interleaved, so they are like a zipper. Yeah, they are just zipped. So always 0, 1, 0, 1, 0, 1. If we look at this in a audio waveform, we can just open, beware it's white now, white mode, close your eyes. This is Audacity, and if we zoom out, you see this is just a usual waveform with a left and a right channel, and if we zoom in, this is our audio data, and what we had here in the test is just stacked data was just a vector of this channel and then a vector of this channel, and interleaved data just means we have it in this, grouped in this. So this is the first frame out of those two samples, this is the second frame, so we just go like this always. And that is also kind of valid because those samples are connected because they are at the same time. Yeah, so those are the different time steps in our array, and they happen at exactly the same time. That is the reason why, for example, in audio hardware or in WAV files, they are stored like this, because maybe we want to read a WAV file only from one time to another time, so we can go time step by time step through our array. But for audio processing, like in plugins, sometimes it's better to store it like this, because we want to do the processing only on one channel, or maybe on two channels, but not on all of them. But usually, I don't know, when you have a delay, or no, for a delay, this could work well. But I don't know, for a specific EQ or so, you process channel by channel. And then it's just more efficient to do it like this, because we don't have to jump around in this array all the time. Yeah, let's try to implement an abstraction over this interleaved data object, because that's a nice use case for iterators, because we need to jump here around. What do we have? From interleaved function, we want to create this. And it actually gets a reference to our data, and then we also need more information to jump around in here. That's at least the number of channels, or the number of channels and the number of frames. In this case, we have 2 channels and 3 frames. Lastly, we want to have a channel function to access one of those channels and see that the first channel is giving us only zeros and the second channel is giving us ones. Yeah, let's get into it. I prepared already the basic buffer struct. Yeah, it's exactly like in the last video. We have an audio buffer. This time we want to store a slice instead of the pointer, just to make it a bit easier here. We still need a lifetime because we don't store the actual data. We just want to have a set of instructions. And yeah, we also store the number of channels and the number of frames here. Then this interleaved from interleaved function is exactly what we specified here, to get all of our stuff. Don't forget, this is the lifetime we want to have for our object as well. So our object and this F32 slice should have exactly the same lifetime. And then we just return self. We return our audio buffer stored with our stuff. One thing I would like to add here is again an assertion. And the assertion should just check that the data and those values we hand in here actually fit together. Not that someone accidentally specifies something that was meant for another data object. So we just say data.length should be equal to number of channels times number of frames. Just to see why. Go back here, we have 2 channels and 3 frames, and 2 by 2 times 3 is then 6 values. All right, so this should already work. And then we want to get the first channel. Maybe let's copy this here so you see what we actually do. So this is our data object here, and now we want to iterate over this or over the first channel. Let's use the first channel as an example, or the second channel. We have our self.data, and now we want to create an iterator. An iterator is nothing else than just a set of instructions of how to iterate over this array. It's nothing more. It's not yet a collection of samples. It's not yet doing really anything. Like, this is extremely cheap to call because it's really just an instruction what to do. And if we return this iterator now, it would be fine, but we would just get the whole array. Maybe just to see how we can iterate over an iterator. Let's store it inside of here and then say this has to be a let, and then for sample in iter debug our sample. Okay. What is the problem here? I didn't close it. All right, so that already works. We have our iterator, we return it here, and then we can just walk along the iterator. So by here, nothing really happened. It's just a set of instructions, and only here we actually walk through it. So now this should print our complete array. But now we want to jump to our actual start, and we always have to start at the index of the channel we specify. So if we want to have channel 1, we want to start here, and if we want channel 2, we start here. There's an instruction that we can use for this that is called skip. There's also skip while, but we just want to skip to our index. And this now will let us start at the right channel. And the second instruction we need is to jump always to the next index of our channel. And this is here actually 2 samples, right? So we jump 2 samples, then we jump 2 samples again, so long until our array is finished. How to do this here? There's an instruction called step by. And step by will do exactly this. So in this case, we need to step by 2, and 2 is our number of channels. So then it will work for every case. So if we have 3 channels, we always need to jump 3 here. If we have 4 channels, always 4, and so on and so on. So now, let's try to run this. It should already work. So we remove this for now. Let's just check channel 1 and run it. Cool. So our first channel, or channel 0, is only zeros and 3 of them. So that's correct. Let's check channel 1, or the second channel. And you see we have only ones. So that worked great. Perfect. But now we want to return it for our user of the object. Let's see how we can do that. You already see there's a return type of implement iterator. But maybe let's remove it for now, because I want to show you what I tried first and where I was a little bit annoyed. So it's recommending you now to return step by, skip, and then iter. So in the return type now you would have all the instructions embedded. And you can do this, it works, but you have a problem that it will now, if you want to change something in here, or you change the layout of your data, you would also need to change this contract, right? This function, the return type of it. And this is a little bit annoying. So that's why, check again what it's recommending when we do this. It shows implement iterator. And this is a cool little tool we can use, this impl keyword. It just means we don't know yet what we return here. We don't know yet what it is, but we know it's definitely fulfilling the contract of an iterator over items of F32. So this is not a specific object, but it's just a generic thing. So iterator is a trait, or in C++ you would say an interface. It's not exactly the same, but it works kind of similar. So the trait iterator has a connected type item, that is in our case reference to F32, and it has a function next that will always go to the next value until there is nothing more to get. So then it will return none. So it's an optional value. All right, let's see if that works. Yeah, right, it compiles here at least. Let's see what is happening here. We get our 2 channels, and now we want to compare that the channel actually contains the whole vector. And this is a bit annoying to do when you see it for the first time, because this channel now, remember, it's only the contract, it's not actually the full vector, so we cannot do it. This is not the similar type. We can transfer it though, and this is done by calling our channel 0 and then .collect. Collect will just walk along this iterator and collect them all in one collection. The only thing that is necessary then is to specify in which collection you want to store it. And this is this vector. So that works. We will receive a vector. But this vector now is still over references to F32. So there's another function we can use that is copied. You could also call .cloned. This will clone all the values inside of the vector and just remove the references by that. So that works, right? Here you see it works. But in this case, we can use copied, as F32 is a small type that can be easily copied. And thus, like copying here is real-time safe, while calling .clone, depending on the type, could be like an operation that is heavy, that is that needs a lot of processing or new allocations, and .copied usually works. But .collect, never call this in a real-time thread. This is at least collecting in a vector, allocates new memory for sure. but it's just nicer to do it like this because we immediately see here in the test what we want to test, what we expect here. And yeah, I just prefer this than making a for loop and checking each value or something like this. Let's do the same for channel 1 and run the test. All right, that worked great, cool. The only thing missing now again is we have no safety protection. For example, we could access channel 3 here, but there is no channel 3, yeah, or channel 2. So what would happen in that case? Let's go back here, or let's check here. We would start at channel 2, so at this sample, and then walk along. So we only get 2 zeros. And yeah, it just doesn't make sense anymore. There is not meant to be a channel 2. So just, I don't know where this is coming from. Let's just assert here again. Assert that index is smaller than our number of channels. And now we have a protection that what we get here is always valid. And yeah, this is how we access the full channel. I think it's a really cool thing. We don't use any resources here. We just give back a contract and then we can walk along this contract when we want to later. So yeah, it's a really cool concept and makes working with interleaved data really nice. And then in a later video, we can check, this was meant differently, but in a later video, we can check how this data or how an audio buffer could be generic over all those different types. Yeah, so we just have an audio buffer, but we don't care if the inner thing is stacked, sequential, interleaved. If we call channel, we just get our channel. Yeah, this is the only thing we care. So I built something like this recently to make it easier to work with audio data, and we can have a look into this, how to create a function like this, a structure. Yeah, that's it. Thank you for listening, and see you next time. Bye bye.